The adoption of generative AI is accelerating rapidly, and organizations across industries are beginning to integrate AI into their businesses. But an important question remains: can AI truly understand enterprise knowledge? Inside every organization, there is an enormous amount of information: PDFs, Word documents, Excel spreadsheets, design documents, technical manuals, meeting minutes, emails, chat conversations, and much more. Yet while humans can read and interpret these materials, most of them are not organized in a form that AI can genuinely understand, reason over, or use effectively. In this video, we introduce knowledge flow, an architecture that transforms enterprise knowledge into an AI-ready knowledge infrastructure, enabling AI to understand, reason about, and utilize organizational knowledge more effectively. Many organizations believe that adopting a more powerful large language model will automatically make their AI smarter, and certainly, the capabilities of the model do matter. However, the real key to enterprise AI is not the LLM itself. What AI truly needs in order to make sound decisions is the organization's own knowledge, its business rules, operational processes, and decision-making criteria. No matter how advanced an LLM may be, it cannot make organization-specific decisions correctly if it does not understand that knowledge. So, what exactly can an LLM do, and what are its limitations? Large language models are remarkably capable. They can read documents, summarize information, answer questions, and generate new content with impressive accuracy. However, that does not mean they understand the knowledge that organizations use every day. Consider, for example, company-specific terminology and abbreviations, detailed business rules and exceptions, approval workflows and authorization policies, the roles and responsibilities of different departments, and the reasoning behind past decisions, along with the experience that shaped them. This knowledge exists within the organization, but it is not knowledge that an LLM possesses by default. So, where does this enterprise knowledge actually reside? Enterprise knowledge is not stored in a single location. It is scattered across PDF files, Word documents, and Excel spreadsheets. It resides in knowledge-sharing platforms such as SharePoint and Confluence. It is exchanged every day through Slack, Microsoft Teams, and email. It is embedded in GitHub repositories, source code, design documents, and technical manuals. In addition, every department, sales, manufacturing, engineering, quality assurance, administration, and maintenance, accumulates its own specialized knowledge over time. In other words, enterprise knowledge is distributed across different formats, different repositories, and different organizational units. As a result, even if AI can gather all of this information, that alone is not enough for it to make enterprise-level decisions. So, if we simply provide these documents to AI, can it actually make the right decisions? Unfortunately, the answer is no. AI is excellent at searching through large volumes of documents, summarizing information, and answering questions, but that is fundamentally different from making decisions. Consider questions such as, does this contract require executive approval? Is it safe to shut down this piece of equipment? Is this quality issue within an acceptable range for shipment? Answering these questions requires much more than simply reading documents. AI must understand business rules, operational constraints, previous decision criteria, and the relationships between different departments. It must then combine all of this knowledge to reason its way to the correct decision. In other words, a collection of documents alone is not enough to support enterprise decision-making. What is needed is a way to transform the information scattered across the organization into structured knowledge that AI can understand, reason over, and apply. That is the purpose of knowledge flow. Now, let's take a look at how knowledge flow makes this transformation possible. Knowledge flow is a comprehensive process for transforming enterprise information into an AI-ready knowledge infrastructure. It begins with the vast amount of information distributed throughout an organization: PDF files, Word documents, and Excel spreadsheets, SharePoint and Confluence, Slack conversations and email, GitHub repositories, source code, design documents, and many other knowledge sources. Enterprise knowledge is scattered across all of these locations. Knowledge flow collects this information, extracts its meaning, and structures it into a form that AI can understand, reason over, and use for decision-making. As a result, AI becomes capable of much more than simply searching for information and generating answers. It can combine knowledge from multiple sources, reason across that knowledge, support context-aware decision-making, and even explain the reasoning behind its recommendations. In other words, knowledge flow transforms the information that already exists within an organization into a continuously evolving knowledge asset that AI can leverage over time. So, how does this transformation actually work? In the next diagram, we'll walk through the complete knowledge flow process, step by step. Now, let's take a look at how knowledge flow makes this transformation possible. Knowledge flow is a comprehensive process for transforming enterprise information into an AI-ready knowledge infrastructure. It begins with the vast amount of information distributed throughout an organization: PDF files, Word documents, and Excel spreadsheets, SharePoint and Confluence, Slack conversations and email, GitHub repositories, source code, design documents, and many other knowledge sources. Enterprise knowledge is scattered across all of these locations. Knowledge flow collects this information, extracts its meaning, and structures it into a form that AI can understand, reason over, and use for decision-making. As a result, AI becomes capable of much more than simply searching for information and generating answers. It can combine knowledge from multiple sources, reason across that knowledge, support context-aware decision-making, and even explain the reasoning behind its recommendations. In other words, knowledge flow transforms the information that already exists within an organization into a continuously evolving knowledge asset that AI can leverage over time. So, how does this transformation actually work? In the next diagram, we'll walk through the complete knowledge flow process, step by step. Let's begin with the first step: document ingestion. Enterprise knowledge is not stored in a single, centralized location. It exists in PDF files, Word documents, and Excel spreadsheets. It resides in knowledge-sharing platforms such as SharePoint and Confluence. It flows through daily communication in Slack, Microsoft Teams, and email. It is also embedded in GitHub repositories, source code, design documents, and many other information sources. In other words, enterprise knowledge is distributed across a wide variety of formats and repositories. The first task of knowledge flow is to collect all of this information and bring it into a unified processing platform. But document ingestion is much more than simply gathering files. It connects to each information source, collects the relevant data, normalizes different document formats into a consistent representation, manages version histories and document updates, and preserves essential metadata such as authorship, timestamps, and access permissions. By consolidating information from diverse formats and storage locations into a unified document pipeline, knowledge flow creates a solid foundation for accurate knowledge extraction and efficient AI reasoning. Document ingestion is the critical first step that determines the overall quality of the entire knowledge flow architecture. Next, we'll explore how meaningful knowledge is extracted from these collected enterprise documents in the knowledge extraction stage. The next step is semantic document chunking, the process of dividing documents into meaningful units. In many RAG systems, documents are split mechanically based on a fixed number of characters or tokens. However, this approach often breaks a business rule or decision criterion in the middle, or combines unrelated information into the same chunk. As a result, the original meaning can be lost, making it difficult for AI to understand the content correctly. Knowledge flow takes a different approach. Instead of splitting documents by size, it divides them according to their semantic meaning. For example, a single chapter, a business process, a decision rule, or an individual event or procedure. Each document is divided into units that humans naturally recognize as a single, coherent piece of meaning, and each of these units is managed as a semantic chunk. In addition, every chunk is enriched with metadata such as the source document, chapter number, version, department, creation date, and other relevant information. This not only enables complete traceability back to the original source, but also simplifies version management, access control, and document updates. The goal of this step is not simply to cut documents into smaller pieces. It is to transform them into the smallest meaningful units that AI can truly understand, creating a solid foundation for accurate knowledge extraction in the next stage. Next, we'll see how knowledge extraction identifies concepts, relationships, business rules, and other forms of knowledge from these semantic chunks. Now let's move on to the next step, knowledge extraction. In the previous stage, enterprise documents were divided into semantic units, making them easier for AI to understand. In this step, we use a large language model to extract enterprise knowledge from those semantic chunks. LLMs are commonly used to answer questions and generate text in knowledge flow. However, we use them in a different way. We use them as a knowledge extraction engine. The LLM reads each document and identifies the important knowledge embedded within it, transforming that knowledge into a structured representation. For example, it extracts entities such as people, organizations, equipment, and products. It identifies relationships that connect those concepts. It recognizes constraints that represent business conditions and operational limitations. It detects events that describe business processes and activities. It captures intent, revealing the goals and purposes described in the documents. And it extracts business rules, including approval policies, quality standards, and safety requirements. Humans naturally recognize this knowledge when they read a document, but for AI to perform reliable reasoning, all of this implicit knowledge must be extracted explicitly, one piece at a time. In knowledge flow, the LLM systematically extracts these knowledge elements, creating the foundational data used to build the enterprise ontology and knowledge graph in the following stages. In other words, an LLM is not merely a model for generating answers. It also serves as a knowledge extraction engine, transforming the knowledge hidden within enterprise documents into a form that AI can truly understand and reason over. Next, we'll explore how this extracted knowledge is unified into a shared semantic framework for the entire organization in the Ontology Builder stage. Next, let's move on to the Ontology Builder stage. In the previous step, the LLM extracted a wide range of knowledge from enterprise documents, including entities, relationships, business rules, and constraints. However, this extracted knowledge cannot yet be used as a unified enterprise knowledge base. The reason is simple. Different departments and systems often use different terms to describe the same thing. For example, the sales department may use the term customer, the accounting department may refer to the same entity as client, manufacturing may call it account, and an overseas system may simply use customer. Humans naturally recognize that these terms refer to the same concept. AI, however, treats them as completely different entities unless they are explicitly connected. This is where the Ontology Builder comes in. It aligns concepts that share the same meaning, resolves synonyms and inconsistent terminology, and maps different expressions to a common enterprise vocabulary. It also defines standardized concept names, organizes hierarchical relationships and classifications, and structures attributes into a consistent semantic model for the entire organization. As a result, AI understands that customer, client, account, and customer all represent the same underlying concept. It can then consistently reason about related concepts such as corporate customers, individual customers, preferred customers, and many others. But unifying terminology alone is not enough. For AI to perform meaningful reasoning across enterprise knowledge, it must also understand how these concepts are connected. In the next step, we'll build a knowledge graph, linking these unified concepts into a network that represents the relationships across the organization's knowledge as a whole. Now let's move on to the knowledge graph stage. In the previous step, the ontology unified different terms and expressions used across the organization into a common set of concepts. As a result, AI can now understand what refers to the same thing. The next challenge is understanding how those concepts are connected. In the knowledge graph, the extracted entities, relationships, business rules, events, and intentions are not stored as isolated pieces of information. Instead, they are connected together as a network of knowledge. For example, a customer places an order. That order contains one or more products. Those products are manufactured at a particular factory. The factory uses specific equipment, and the equipment has been inspected through quality assurance procedures. Rather than treating these as separate facts, the knowledge graph captures them as a chain of connected relationships. This enables AI to do much more than retrieve individual pieces of information. It can reason across multiple connected relationships. For example, which customers will be affected by this quality issue? Or, if this piece of equipment is taken offline, which products and customer orders will be impacted? These kinds of multi-step reasoning tasks become possible because AI can traverse the network of connected knowledge. Furthermore, because every conclusion can be traced through the graph, the system provides both traceability, the ability to track the evidence behind a decision, and explainability, the ability to explain why a particular conclusion was reached. In other words, a knowledge graph is far more than a repository of information. It is the foundation that connects enterprise knowledge into a network that AI can reason over. However, reasoning alone is not enough to support enterprise operations. Every organization has countless business rules that define what decisions should be made under specific conditions. These rules must be transformed into a form that AI systems and enterprise applications can execute reliably. That is the role of the next stage, the DSL generator. Now let's move on to the DSL generator stage. In the previous step, the knowledge graph organized enterprise knowledge into a network of interconnected relationships. This enabled AI to understand how knowledge is connected and to perform multi-step reasoning. However, in real business operations, reasoning alone is not enough. AI must also make decisions according to business rules and execute those decisions reliably within enterprise systems and AI agents. Enterprise documents contain a vast number of these decision rules. For example, if the contract value exceeds 10 million yen, director approval is required. If the equipment temperature exceeds the specified threshold, production must be stopped. If a product fails the quality inspection, it must not be shipped. Humans can read these statements and understand the required actions naturally, but AI systems cannot execute ambiguous natural language directly. To automate these decisions, the rules must first be transformed into an executable representation. In knowledge flow, the LLM extracts business rules from enterprise documents, validates their contents, and converts them into a domain-specific language, or DSL. For example, the statement, if the contract value exceeds 10 million yen, director approval is required, is transformed into an executable rule such as, if contract value, 10 million yen then approver equals director. This representation can be executed directly by AI systems and enterprise applications. By converting natural language into executable knowledge, organizations can eliminate inconsistencies in decision-making and reduce differences in human interpretation. Furthermore, because these rules are managed as structured knowledge, they can be updated, extended, and maintained as business requirements evolve. However, creating executable rules alone does not complete an enterprise knowledge infrastructure. Organizations also need a centralized repository to store and continuously manage their rules, constraints, policies, and all other forms of enterprise knowledge. That is the role of the next stage, the knowledge repository. Now let's move on to the knowledge repository stage. Up to this point, we have extracted knowledge from enterprise documents, unified its meaning, connected related concepts, and transformed business rules into executable forms. But enterprise knowledge is never static. It is not something that is created once and remains unchanged. Organizations continuously produce new documents. Business rules evolve. Organizational structures change. Products and services are updated. To ensure that AI always works with the latest knowledge, organizations need a centralized platform for storing, managing, and maintaining their knowledge assets. That platform is the knowledge repository. The knowledge repository integrates and manages every form of knowledge used by AI, including ontologies, knowledge graphs, DSL rules, policies, constraints, and even decision patterns. As a result, enterprise documents are transformed from isolated collections of information into continuously evolving knowledge assets that AI can leverage. These knowledge assets are not designed solely for information retrieval. They enable AI to combine knowledge and perform reasoning. They allow business rules and constraints to be validated. They can be executed directly by enterprise applications and AI agents. And they make it possible to explain why a particular decision was made. In other words, the knowledge repository serves as the central knowledge foundation that enables AI to operate effectively across the enterprise. However, even a comprehensive knowledge repository is not enough. Enterprise knowledge is constantly changing. Therefore, the knowledge infrastructure itself must continue to evolve. In the final step, we'll explore how knowledge flow continuously learns, updates, and grows its knowledge over time. So far, we've seen how knowledge flow transforms enterprise documents into knowledge assets that AI can use. The knowledge repository accumulates the knowledge required by AI, including ontologies, knowledge graphs, DSL rules, policies, and operational constraints. But there is one essential point to remember. Knowledge cannot be completed by AI alone. Large language models can read vast amounts of documentation and rapidly extract concepts. relationships, business rules, and constraints. They can also propose new knowledge, detect changes in existing documents, and suggest additions or modifications to business rules. However, only humans can determine whether that knowledge is truly correct for the organization. Every enterprise has exceptional procedures, tacit knowledge, and practical experience that cannot be fully captured in documents. That is why human experts must review the knowledge, refine it when necessary, approve it when appropriate, and reject it when it is incorrect. Humans are also responsible for governance, deciding which knowledge becomes part of the organization's official knowledge base and defining the policies that govern its use. In knowledge flow, AI extracts and proposes knowledge, while humans validate it and ensure its quality. This human-in-the-loop process allows enterprise knowledge to grow into a trusted and reliable organizational asset. But even after knowledge has been reviewed and approved, the process is not complete. Organizations continue to evolve every day. Their knowledge must evolve as well. In the next section, we'll explore how knowledge flow continuously updates and grows enterprise knowledge over time. Knowledge flow is not a system that is built once and then left unchanged. Enterprise knowledge evolves every day. New products are developed, designs are revised, business rules are updated, new regulations and quality standards are introduced. In other words, enterprise documents are constantly evolving. As those documents change, the knowledge stored in the knowledge repository must evolve as well. In knowledge flow, whenever new documents are added or existing documents are updated, the knowledge extraction process is triggered automatically. The newly extracted knowledge is incorporated into the ontology. The knowledge graph is updated. Business rules are regenerated as executable DSL after human review and approval. The updated knowledge is registered in the knowledge repository. This quality-assured knowledge then becomes the foundation for the next cycle of updates, allowing enterprise knowledge to grow continuously over time. By repeating this continuous cycle, the knowledge infrastructure remains accurate, current, and aligned with the organization's evolving business. As a result, AI can keep pace with new business rules and design changes while retrieving the knowledge it needs, reasoning across multiple knowledge sources, validating business rules, executing decisions within real business processes, and explaining the reasoning behind those decisions. In other words, knowledge flow is not simply a knowledge base that is created once and maintained. It is a living knowledge infrastructure that learns, grows, and evolves together with the organization. But even a continuously evolving knowledge base is only part of the story. The real value comes from applying that knowledge in day-to-day operations to support both human and AI decision-making. In the final section, we'll see how the knowledge cultivated by knowledge flow is put into practice to enable intelligent enterprise decision-making. So far, we've explored how knowledge flow transforms enterprise documents into knowledge assets that AI can use. But the knowledge created by knowledge flow is not simply stored in a repository. Its true value is realized only when it is applied in real business operations. Knowledge flow continuously extracts knowledge from enterprise documents, builds ontologies, knowledge graphs, DSL rules, policies, and constraints, and keeps them up to date as the organization evolves. This continuously evolving knowledge is then delivered to the decision runtime. Within the decision runtime, the decision runtime kernel understands the current situation and business objectives, and integrates the knowledge provided by knowledge flow. At the same time, the runtime OS coordinates AI agents, enterprise applications, and the execution environment as a whole, enabling appropriate decisions and actions to be carried out. In other words, knowledge flow is the knowledge infrastructure that continuously builds and evolves enterprise knowledge. The decision runtime, on the other hand, is the execution infrastructure that uses that knowledge to reason, make decisions, and drive real business operations. However, enabling AI to make decisions is only part of the challenge. Organizations also need to understand why those decisions were made, which knowledge was used, what reasoning led to the final conclusion. Making the decision process transparent and understandable is essential for building trust. In the next section, we'll explore the decision trace model, which makes AI decision-making visible, traceable, and explainable. So far, we've seen how knowledge flow generates AI-ready knowledge, and how the decision runtime uses that knowledge to make real-world business decisions. But how are those decisions actually made? And more importantly, how can they be explained? That is the purpose of the decision trace model. The decision trace model is an architecture that makes AI decision-making transparent, traceable, and explainable. AI does not simply jump to a conclusion. It begins by understanding the need. What problem must be addressed? Next, it defines the goal. What outcome should be achieved? It then analyzes the context to understand the current situation. Based on that context, the AI consults the knowledge generated by knowledge flow. Business rules and operational constraints are applied as constraints. Organizational policies and corporate guidelines are referenced as policies. The AI also draws upon the ontology, the knowledge graph, executable DSL rules, and the knowledge stored in the knowledge repository to understand the situation and evaluate possible alternatives. In addition, it refers to previous decision histories to maintain consistency across similar situations. By integrating all of this information, the AI arrives at the most appropriate decision and executes the corresponding action. Finally, it records the complete reasoning process as a trace. In other words, it captures the objective it was trying to achieve, the context it recognized, the knowledge, rules, policies, and constraints it consulted, and why it selected one course of action over the others. Every step of the decision-making process can be reviewed and traced afterward. As a result, AI decisions are no longer a black box. People can examine the reasoning, verify the decision, and continuously improve the decision-making process over time. Knowledge flow continuously builds and evolves enterprise knowledge. The decision runtime uses that knowledge to reason, decide, and act, and the decision trace model makes every decision transparent, traceable, and explainable. Together, these three components transform AI from a system that simply generates answers into a trustworthy decision-making platform, one that can reason with evidence, make informed decisions, and clearly explain the rationale behind every action. So far, we've explored the overall architecture of knowledge flow, but how does it differ from a traditional RAG system? Conventional Retrieval Augmented Generation, or RAG, retrieves relevant documents, identifies similar information using embeddings, and generates answers based on the retrieved content. In other words, its primary goal is to find the information that is needed. Knowledge flow, however, goes far beyond document retrieval. It begins by extracting meaning from enterprise documents and unifying concepts through an ontology. It then structures the relationships among those concepts using a knowledge graph, enabling AI to reason across multiple pieces of knowledge rather than treating them as isolated documents. Next, it transforms the business rules and decision criteria embedded in enterprise documents into executable domain-specific language, DSL, rules that AI systems and enterprise applications can directly use. Finally, it records both the decisions and the reasoning behind them through the decision trace model, enabling explainability, traceability, and continuous improvement. In other words, knowledge flow is not a document retrieval system. It is a knowledge infrastructure that structures enterprise knowledge, supports reasoning, enables execution, and continuously learns as the organization evolves. If RAG is designed to retrieve information, knowledge flow is designed to cultivate knowledge itself, transforming enterprise information into a continuously evolving asset that AI can understand, reason over, and apply. That is the fundamental difference between knowledge flow and traditional RAG. So far, we've explored the overall architecture of knowledge flow. The goal of knowledge flow is to transform enterprise knowledge into a knowledge infrastructure that AI can truly understand and utilize. To achieve this, knowledge flow delivers 6 key values. First, a shared semantic foundation. Within an organization, the same term can have different meanings depending on the department or the individual using it. Through its ontology, knowledge flow unifies terminology and concepts, creating a common semantic understanding across the entire enterprise. Second, structured knowledge. It extracts concepts, relationships, and constraints hidden within enterprise documents, transforming them into knowledge that AI can understand and reason over. Third, executable rules. Decision criteria described in manuals, procedures, and corporate policies are converted into executable domain-specific language, DSL, rules, transforming human-readable documents into machine-executable knowledge. Fourth, explainable decisions. Through the decision trace model, every AI decision is accompanied by its reasoning process, including the knowledge consulted, the rules applied, and the rationale behind the final decision, providing both transparency and traceability. Fifth, continuous evolution. As new documents are created, designs change, and business rules evolve, knowledge flow continuously incorporates these changes, allowing the knowledge infrastructure itself to grow and improve over time. And sixth, human-AI collaboration. Rather than replacing human expertise, knowledge flow combines human experience and domain knowledge with AI's reasoning capabilities to enable better, more reliable decision-making. In other words, knowledge flow is neither a document management system nor a document retrieval system. It is a knowledge infrastructure that transforms enterprise knowledge into a form that AI can understand, reason over, make decisions with, execute, explain, and continuously improve. The question, then, is this: how will this knowledge infrastructure become a source of competitive advantage for enterprises in the age of AI? As we've seen throughout this presentation, knowledge flow is a knowledge infrastructure that transforms enterprise knowledge into a form that AI can truly understand and use. But what kind of competitive advantage does this infrastructure create? In the age of AI, competitive advantage will not be determined by having a larger or more powerful AI model. Of course, high-performance large language models are important, but when every organization has access to the same foundation models, the model itself is no longer the differentiator. The real source of competitive advantage is organization-specific knowledge. It is the expertise accumulated over many years, the engineering principles, the quality standards, the business rules, the decision-making practices, and the practical experience gained in day-to-day operations. These are the assets that competitors cannot simply copy. Equally important is the ability to evolve that knowledge continuously. As new products are developed, business processes improve, regulations change, and markets evolve, the enterprise knowledge infrastructure must evolve as well. Finally, that knowledge must be applied to real decision-making. AI should do more than generate answers. It should understand organizational rules and constraints, support consistent decision-making, and clearly explain the reasoning behind every recommendation. In other words, competitive advantage in the AI era will not come from possessing a better AI model. It will come from how effectively an organization can structure its unique knowledge, continuously evolve it, and apply it to real-world decision-making. Knowledge flow is the knowledge infrastructure that makes this possible. It preserves enterprise knowledge for the future, transforms it into a strategic asset for AI, and turns that knowledge into lasting competitive advantage. That is the vision of knowledge flow, building the knowledge infrastructure for the AI era. Throughout this presentation, we've introduced knowledge flow, a new architecture for the AI era. The real challenge is not simply adopting more powerful AI models. It is transforming the knowledge that organizations have accumulated over many years into knowledge that AI can understand, reason over, and put into action. And it is about continuously evolving that knowledge so it can support decision-making across the entire organization. Knowledge flow provides the foundation for making that possible. It transforms scattered enterprise documents into knowledge. It transforms knowledge into decisions, decisions into actions, and the results of those actions into new learning for the future. Through this continuous cycle, enterprise knowledge evolves from a collection of information into a strategic asset that drives long-term competitive advantage. Knowledge flow is the knowledge infrastructure for the AI era. If you found this research interesting, we invite you to visit the Chinoba Research website, explore our research blog, and subscribe to our YouTube channel. We will continue to share new research on the architectures and knowledge infrastructures that enable AI and humans to collaborate more effectively. Thank you very much for watching.